it's not coming out correct. So one of you guys probably knows how to rotate that screen. I think it's like Control something H, or there's some kind of way to rotate the screen. So if any of you guys know that, can you post it in chat so everyone could do that? Because otherwise you're going to be looking at it sideways. Okay, now we're going to do something cool today. We're going to do, let's see, no, you do not have to use all the resources. Those are just options, Nathan. You can use some of them. You don't have to use all of them. In fact, some kids used barely any of them, and they were still pretty strong. So I was really impressed with that. Okay, well, if you have a Surface, that's an easy fix. Just turn it. Okay, so if you haven't noticed yet, there's a presenter on your Zoom that says Augustinelli, and that's what you're going to want to go to, okay? Go to the one that says Augustinelli and highlight that or double click on it or whatever you do to get it to be full-sized on your screen. And we're going to do something cool today. So I got to switch all the mics over, so give me about 30 seconds to do all that. Okay, very good. Let me turn this. Okay, let's see here. Hey, Connor, can you hear me? If you can, nod, please. You can? Okay, good. Perfect. Okay. Now I just got to turn that volume down. Okay. Awesome. I think we're in business. So here is what we are doing today. So in the advanced woodshop class, you got to do this thing called fractal burning, okay? Fractal burning. And what it involves is we're going to take, and I know everyone's going to like this because it involves burning and high voltage electricity. So I know you guys are all fans of all that stuff. So where's my camera? Okay, so this is the plug coming out of the wall. You guys are probably familiar with this. It is a 120 volt plug, okay? If you've taken robotics, you know what that means, but it's coming in at 120 volts. Well, that's not enough to push the electricity where we want it. Because what we want to do is, see if that'll come in clear. See if I can zoom it in a little. I don't know how clear that is, but this thing makes these really intricate burn lines in there, and they look like coral or like a Japanese bonsai tree, kind of look like that. So it makes these really cool patterns, but we're going to use electricity to burn it into this wood. Wood is an insulator. It does not pass electricity. It does not want to let electricity go through it. Okay, it tries to resist electricity. However, if you can take this 120 volts and bump it up to 12,000 volts, well, now all of a sudden we've got a different story, because now that electricity is going to want to push through this wood. Even though the wood's going to resist it, we're going to put so much electricity through that wood, it can't resist it, okay? So let me plug this thing in. And we will get going. I love even the name, Lichtenberg burner. Just cool. Kind of reminds me of Dracula, Transylvania and all that. Lichtenberg, okay? Lichtenberg burner. So we're going to take this piece of wood, and remember, wood is an insulator. It's not going to want to let electricity through. So we're going to help it out a little bit. We're going to put this solution of baking soda and water on the wood. Now, water is not a great conductor, but it helps conduct. So it's going to turn this board that's an insulator into a conductor, at least a decent conductor, okay? Still not great, but with enough voltage, we'll be able to use it. Now, this is our burner here, and I don't know if you could see, but there's two probes. And what it's going to do is it's going to try to send high voltage out of one probe and make it catch it on the other probe. So it's going to try to go out one and catch it on the other and pull it back in, okay? So we got two probes. We're going to put these onto the wood to do the burning of it. However, because this thing is such high voltage, it's going to push the electricity through. And because of that, you're going to see me use these funky gloves. Now these are specialty gloves, and while it won't come through on this camera probably, they're rated at 20,000 volts. So this is like electrical armor. It protects me from electricity, and will protect up to 20,000 volts, okay? Supposedly. Now it is from China and they were cheap, so I don't know how much I would trust it. If I was actually using 20,000 volts, I probably wouldn't be using these. But anyways, they'll be good for this. This one will put out 12,000 volts, and I'm gonna keep my hands on the insulated controls, so I should be good. It shouldn't be a problem, okay? So I put the baking soda water solution on the wood. It's sitting there, and actually I gotta grab my safety glasses. Because I would not want to be a pirate when you guys come back. I would like to be just like I was when you left. All right, so let's go ahead and do some burning here. So we've got our wood. We're gonna put our 2 probes down. I'm gonna start close for the first one, and then we'll make them farther away. There's a little gas pedal here, and I'm gonna hit the gas pedal, and it's gonna charge these up. Now, if you see me start shaking on this, that means that electricity got through somehow and it's electrocuting me. You would not want to come over and push me because you would get electrocuted. So you would want to use like your foot or a broom handle or something that's doesn't pass electricity. Otherwise, you could get shocked too. So if you ever see someone getting shocked, kick them with your foot so that the rubber of your shoe insulates you and you can knock them away from the electricity that way. Okay, don't just grab them with your hand. Here we go. So I'm turning it on, and you're gonna start seeing the flames and smoke going. And what it's trying to do is pass electricity from one probe to the other. You can see it's burning this weird circuitous path. And even though it seems weird, that's actually the path of least resistance, even though it's all over the place. And I don't know if it showed up on the camera or not, but it did something that's really cool that I love when it does. And let's see. If you can tell, it burned around the corner. And I love when it does that because it makes a 3D effect that like washes like a waterfall right over the edge. So I noticed the end grain seems to conduct electricity better, which makes sense because that's probably how the water moves around in there. And so it makes that cool pattern, and the electricity burns. So I'm gonna do another one now, but I'm gonna keep the probes farther away. So this is a lot harder work. The electricity has to work a lot harder for this one. And I wish I could zoom on that iPad. I tried to zoom in real close to you, but unfortunately I can't get it to zoom. So this is kind of weird. It's going around the edge where it went the first time, and then got this weird spot in the center that it's going. And yeah, that's really cool. Let me turn this off. So it did this weird circle pattern. It started from this probe and it came all the way around and went down the side and then came back over here. Oops, let me get that in the screen. Yeah, it came all the way around, down the side over here and up and over. So really kind of cool the way that worked. I would never have expected that. Let me see if I can get it to go over here. Still trying to go around that curve like that. So that must be, I'm gonna show you a hypothesis when I'm done here. So we're burning it, and I don't know if it shows on camera, but you can see sparks over the whole board right now. It's really trying to find its path. And it seems like it's trying to continue the old path again. Okay, I'm gonna turn this off, blow the smoke out of here. So even though it's so close to go from one probe to the other, you know, it's only like 3 or so inches there, even still, the electricity is flowing all the way around, down the side, and then up and around. And it's because that's the path of least resistance. And I'm just gonna speculate here. This is my pure scientific conjecture, but I notice on this side of the board, it's really tight grained. The grain is, in fact, let me just show you. So on the side where it's burnt, the grain is really, really tight. And then on the other side, you can see it's spread out quite a bit. The grain is spread out a lot. So my guess is that the tighter the grain, the better it passes electricity back and forth, which makes sense because each one of these grains is kind of the ring of the tree. And the tighter they are, the closer the wood is together. It's real tight. There's not as much air gap in there. So that's my guess as to what's happening, though I don't know. It'd be an interesting scientific experiment to keep doing it and figure that out. I'm going to keep doing this today for all the other classes, so I'll keep an eye out and check it out. Okay, let me see something here. I'm going to unplug this because I do not want some random person coming over and shocking themselves to death with it. So I'm going to unplug that. And let me go back to my regular screen.
You're on mute.
Okay, you guys can hear me now, right? Okay, good. All right, so that's what I wanted to show you today. So that's a really cool thing. Actually, let me grab one real quick. So that's a very, very cool thing that we have in the shop here. Here's a box that's had it done to it, where you can see all the paths snaking around. There we go. So it makes this really, really cool effect on your projects. And it's something that I love doing. When I first saw it, I was so excited about it because I'd never seen anything like it before. We do lots of wood burning in our class, but for you advanced guys, I saw that, I'm like, oh, we got to get one of those. So I haven't seen too many schools that have one of those. As far as I know, we're the only one around anywhere in this area that has one. So it's a very, very cool effect. And what I've really, really been waiting for is somebody to do the Thor's hammer and do the Lichtenberg burner on it. Now, how cool would that be? So you have all those lightning bolts on the Thor's hammer project. So as the advanced class, you guys can always do the Thor's hammer, although this year's kind of weird. Who knows how much time we'll have, but that's the goal. So you guys will all be able to use that Lichtenberg burner, and I'll do one more demonstration when we're in person just to make sure everyone gets the safety on it, because it is really high voltage and it's very easy to have an accident if you don't know what you're doing. So we will definitely do that. Okay, let me see here. I got some chat going and see if there's any questions. I couldn't see chat during that presentation, so if you were asking me questions, I apologize. I couldn't see it. Yeah, Sarush asked about turning the video 90 degrees. I can't figure out how to do it. It's coming correctly through the iPad, but for whatever reason, it's vertical on yours. There is a way to change it. You guys can do it. It's like Control H or something. I'll have to look it up after class, but there is a way you guys can rotate it. Yeah. Nathan, definitely. It's really majestic. And when you add like that lightning bolt effect, like I did one with a dragon, and some of the dragons can breathe lightning bolts. And that's one of my goals is I want it one time to have it perfectly where it comes out of the dragon's mouth like that. I thought it would just look awesome. So lots of cool art stuff we can do in the wood shop. Let's see, can I buy that piece of wood? You guys can make these pieces of wood. If you were in class today, I'd just give it to you. It's not that big a deal. It's a simple thing to do. It doesn't take a lot of time, but it is very, we have to be highly safety conscious on it because it is 12,000 volts of electricity. So, okay, so let me keep going through. Okay. All right, Sarush said he found it. Go to settings, and then it shows your video and video settings. there is a 90 degrees at the top right. Okay, let me just try that real quick. Of course, then I'll have to figure out how to do it on the iPad too. Settings, video settings. Yeah, he's exactly right. Okay. Okay, where's the one that turns it though? Only problem, Sarush, is I'm not seeing the 90 degrees thing you were talking about. As much as I hate doing all this stuff, I do like learning all the different skills. Let's see here. You said it's at the top right, huh? Oh, you're right. It's at the picture. Genius. That's amazing. Now I'm going to have to do my video upside down for you guys every day. Okay, I know. Hey guys, it's only like 3 weeks and we'll be back and then we can put this stuff to rest. Yeah, I'm looking forward to it too. It's like, you don't know how much I'm tired of just looking at little squares on the computer. I want to see actual people. Like, I love watching kids learn this stuff. It just makes me happy to see. All right, so good job, Sarush, on that. Those are the kind of skills we want you to get, guys. That's what we're good at, is figuring out how to fix things. People hire us when the problems are too complicated for them. Okay, let's see here. Second period, 57. Oh, we already ran over time. So I am going to bid you all adieu and see you guys tomorrow morning, okay? Have a good one.